You are listening to the Vocal Technologist. Spoken tech for your ears.
If you felt like you need a crash helmet just to read the tech headlines lately, you are absolutely not alone.
Not at all.
The speed at which AI is shifting and iterating, it's not just fast, it's dizzying. It feels like every single week we're processing a whole quarter's worth of changes.
That's just the reality of a frontier technology. I mean, the sheer volume of new models, new architectural decisions, new UIs rolling out, it could easily lead to massive information paralysis.
Right. And so our mission today is really to give you a necessary shortcut. We're going to cut through that torrent of information and focus on the core tectonic movements happening right now.
From top to bottom of the stack.
Exactly. From how you talk to a chatbot all the way down to the silicon that powers it. The goal is for you to walk away from this discussion quickly grasping the current state of AI, the good, the frustrating, and, the genuinely weird.
And I think the best place to start is where most people actually touch this technology.
The consumer experience.
The consumer experience, yeah. The dominant trend right now is personalization. AI is moving from this static, generalized tool to something you can actually sculpt to your own preferences.
Okay, let's unpack that because it's so relatable.
Yeah.
The most immediately useful news is how OpenAI is letting us tinker with the fundamental personality of ChatGPT.
Right.
No more typing, be enthusiastic, and use emojis at the start of every single chat. You can now adjust the model's core demeanor. Things like enthusiasm, warmth, and emoji used directly in the personalization menu.
You just set it to more, less, or default.
Exactly.
What's fascinating to me here is the shift in the interaction design itself. This moves way beyond that old school technique of just, telling the model to write in the style of X.
It feels more structural.
It is structural customization. You're defining the baseline tone of your interaction partner, which makes the AI feel much more integrated into your workflow. It's less like a one-size-fits-all product.
Yeah, lowers the cognitive load.
It does.
And speaking of tailoring the user experience, Google's NotebookLM is also showing some real forward thinking in how it delivers dense information. They're testing a new 30-minute AI lecture format.
Which is fantastic for audio overviews.
A great way for busy people to digest complicated info.
And they can produce these in different languages based on user settings, which is a huge accessibility win. But I think critically for anyone who needs to pull insights quickly, NotebookLM also introduced data tables.
So this synthesizes information from your uploaded stuff, all your notes, your articles.
Aren't that unstructured text, yeah.
And turns it into clean, structured, exportable tables.
Right into Google Sheets.
So we're talking raw synthesis into a usable format ready for analysis. That takes hours of manual work down to seconds.
Absolutely. That is a clear victory for the user.
But let's use that success as a bridge to the business side. There's a really crucial nuance emerging in how we measure the popularity of these platforms.
Yes. Specifically around OpenAI's user metrics.
This requires some attention, doesn't it?
Right.
It does. It raises a really important question about scale and, crucially, about retention. OpenAI made a very deliberate decision to report weekly active users, or WAU.
Instead of the standard MAU, monthly active users, which everyone else uses.
Right, which is the baseline metric used across virtually all large consumer tech products.
So why does that distinction matter so much?
Because it makes their user base largely incomparable to competitors like Google or Meta. You're comparing apples to elephants if you put a WAU number next to an MAU number. The implication, especially when you look at the relative scale, is that ChatGPT's user retention, it might be quite low.
So you're saying it's high churn, like a gym membership where everyone signs up in January, so the MAU looks great, but the WAU shows you who's actually showing up every week.
That's a perfect analogy, precisely. If retention is weak users dip in for a specific task and then cycle out for a month, that MAU number would look artificially inflated compared to the core dedicated user group.
So you have to constantly acquire new users just to maintain growth.
Which implies a volatile business model. Usage is high, but that long-term dedication might be low.
That analysis of metrics sets us up perfectly for the next big headache in the AI world, which is benchmarks. It feels like every week there's a new SOTA state-of-the-art model that supposedly dethrones the last one.
Oh, yeah.
Why is it so incredibly hard to interpret if we're actually getting smarter AI?
Because the simple answer is that benchmarks are the most widely misunderstood part of this entire ecosystem. They create this narrative that suggests a clean, linear, universal increase in intelligence.
But that's not what's happening.
No, the numbers can be incredibly misleading. Benchmarks are always narrow and they can be gamed.
So if you're trying to assess a new model for your business, how should you navigate this flood of soda claims?
You have to look at the aggregate performance across dozens of tests, look for consistent relative improvements, and then, most critically, verify performance with your own specific tasks.
Right.
If a model gets a soda title on some niche academic test, but it falls apart solving your actual problem, well, the title is irrelevant. The only benchmark that truly matters is your own workload.
That is the pragmatic truth. And it brings us directly to a concept I find so helpful for describing AI's current state: the jagged frontier.
The jagged frontier. It's the technical reality that confirms that pragmatic advice. AI is not a universal intelligence. It's a brilliant savant. It's incredibly good at certain tasks, synthesizing data, translating code, but it's surprisingly weak at others. Things like basic common sense or long-term planning.
It's the student who can solve advanced calculus but can't remember where they put their keys.
Exactly. And this jaggedness is expected to remain a big part of AI for the foreseeable future, even as the frontier itself keeps advancing.
And we even see this problem in how the frontier labs themselves are evaluated. There was this intriguing note about the METR plot issue.
Right, the plot that's supposed to measure horizon length, or how far ahead labs can predict AI capabilities. The problem is, the topics they use in that evaluation, they're public.
Oh. So that introduces the risk that labs can just...
They can optimize their models specifically for the test subjects. It makes it easy to game those measurements, which suggests the whole plot might be adding very little meaningful information beyond, basic benchmark accuracy.
Which undermines the whole goal of predicting general progress.
It does. You have to look past the marketing.
That suspicion around metrics leads us perfectly from model capability to agent capability. This is where we expect AI to move from being a chat partner to an autonomous worker.
The assistant that runs your life?
Yeah. But the core challenge is simple. If we can train an AI to write perfect code, why does it still forget the instructions we gave it 5 minutes ago?
The memory problem. It's central to making reliable agents. We made them capable, but we haven't figured out how to make them learn in a persistent way. Not yet.
So what's the leading strategy right now?
The data suggests it's structured summarization.
Can you explain that simply? Why is that better than just making the context window bigger and bigger?
Well, expanding the context window is like recording a 4-hour lecture and asking the student to find one key sentence. It's inefficient, it's expensive.
Okay.
Structured summarization, on the other hand, is like teaching the agent how to take organized, categorized lecture notes in real time. It retains more useful, actionable information without sacrificing efficiency. It's focused compression.
But if we deploy these capable agents onto the open web, that capability comes with some scary security dangers.
It does. Prompt injection remains an unsolved and persistent threat.
So this is where malicious instructions are hidden inside, say, a website the agent is browsing.
Exactly. And those instructions can hijack the agent's inner monologue, basically, and manipulate its behavior. It causes it to ignore your prompt and follow the malicious one instead.
And as agents like Atlas OpenAI's browser agent expand what they can do, like execute transactions,
the threat becomes exponentially more acute. If your agent can manage your banking, a malicious website suddenly has a very powerful target.
right, the stakes are so much higher than just getting a weird response in a chatbot.
Oh, much higher.
So the danger is real, but sometimes the fix for all this complexity is completely counterintuitive. I found the Vercel case study absolutely fascinating.
Oh, yeah, the text-to-SQL agent.
They spent months building this complex thing with dozens of specialized tools, but it was fragile. Then they did something drastic.
They adopted radical simplification. The team removed 80% of their specialized agent tools
80%.
and stripped the agent down to a single tool that just executes arbitrary bash commands. They gave it a simple, sharp knife instead of 100 delicate implements.
Yeah, the result.
The agent got simpler, more robust, and its success rate jumped from 80% to nearly 100%.
Wow.
The lesson there is critical. For agent reliability, sophistication is often the enemy. Minimizing the complexity often maximizes reliability.
That is a beautiful counterpoint to the endless complexity we usually see. But if that worked, why are labs still building agents with hundreds of tools? Are the benchmarks measuring the wrong thing?
They're measuring a maximum possible capability, not reliability in the wild. But developers need tools to make these systems robust, and that's why we see things like Anthropic's Bloom emerging.
So it's Bloom.
It's an open source evaluation tool. It's designed for automated behavioral evaluations, so it creates realistic scenarios to check for subtle failures like self-preferential bias or even sabotage.
I see. And then you have specialized benchmarks like SGI Bench for scientific intelligence.
And frameworks like Stirrup, which is really interesting because it lets the models choose their own approach to completing a task. It tries to foster more flexible planning.
That's the technology that tries to give the agent that intuition we were talking about.
Exactly.
Let's shift to the engine room now, the pure technical backbone. We saw a flurry of new model releases aimed at achieving both efficiency and capability. Z.AI launched GLM 4.7.
Claiming new SOTA status for coding and reasoning. Then there's the incredibly efficient MIMO V2 Flash.
We're also seeing smaller players like Minimax M2.1 catching up in key areas.
That capability gap is closing rapidly. But the real structural story in the engine room right now is model distillation.
This is a huge trend. It affects the bottom line for everyone using AI.
Absolutely. Look at a model like Gemini 3 Flash. Model distillation is where you take a massive, powerful teacher model and use its outputs to train a much smaller, lightweight student model.
So Gemini 3 Flash is optimized for speed and low latency.
And it delivers performance that's comparable to the huge, expensive Pro version, but at a fraction of the cost.
So you sacrifice a tiny bit of token efficiency for massive gains in speed and cost. That seems like an essential trade-off for any real-time application.
For most high-volume real-time apps, speed often trumps that marginal gain in raw capability. It democratizes access because it makes the inference cost sustainable.
Which lines up with Andrej Karpathy's 2025 predictions. Fast inference engines, model distillation, real-time agents.
He also predicts the rise of high-quality open models and neural GPUs. It's all moving in that direction.
And the ultimate goal of all that engineering is deploying this power everywhere, not just in data centers.
Right. Portability and privacy. That's where a tool like Executorch becomes indispensable. It's built by PyTorch and Meta specifically for on-device deployment.
So the AI models run directly on your phone or your headset.
Which is why when you use an AI feature in Instagram or WhatsApp, it feels instant.
And it works even if your connection is spotty.
Exactly. It removes the latency of hitting a server farm, and it keeps your private data on your device.
And for those building in the web browser, there's JAX.js.
Correct. JAX.js brings high-performance kernels right to JavaScript so you can run complex models locally inside a browser tab. Deployment is moving aggressively to the edge.
So, to synthesize all this, it feels like we've made these incredible strides in making AI easier to use, personalization, simpler tools, hyper-efficient models. But the fundamental hard challenges of reliable learning, memory, and security.
Yeah.
That's still the jagged frontier we're fighting on.
We're building the engine faster than we're building the steering column and the brakes.
Yeah.
And if you zoom way out, the philosophical implication is profound. This technology will inevitably conquer territories in reasoning, creativity that we once thought were exclusively human. It's leading us towards the first time humanity will truly face otherness.
A new species of being born from computation.
Essentially, yes.
That is a weighty thought to end on. But it brings me to one final challenge, a final fact for you to mull over. We've talked about infrastructure and efficiency, but let's talk about the original benchmark.
The one Mother Nature set.
Precisely. Mother Nature hosts human intelligence. Everything we can do. Our consciousness, our reasoning inside our skull, using only 20 watts of power.
Just 20 watts, a shockingly small amount of energy.
And what we're building today requires massive data centers, specialized cooling, billions in power grid investment just to train the models, let alone run them.
The scale is completely different.
Exactly.
Yeah.
So considering that staggering energy cost, how long will it be until efficiency, not just raw capability, becomes the ultimate benchmark for success in AI? That 20-watt skull, that's the next major inflection point for you to watch.
Spoken Tech for your ears.